Okay students, so let us continue. Let us start with the thermodynamics of cell reaction. Thermodynamics of cell reaction. So we know in a galvanic cell, electrical energy is produced as a result of a chemical reaction that takes place in anode and cathode. So here chemical energy is converting into electrical energy. So let us have an equation to find how much electrical energy is produced. So electrical energy produced is equal to electrical energy produced equal to always proportional to the amount of electricity that is passed through the cell into EMF of the cell. It is the quantity of electricity, quantity of electricity, quantity of electricity that passes through the cell into EMF of the cell, into EMF of the cell. We know the quantity of electricity that is passing through the cell is always proportional to the electron that now transferred between anode and cathode. So that we know it's no flow of electron is actually electricity. So we know one more thing, if one mole electron is transferred within the cell means no, the amount of electricity produced is 1 farad that we discussed in the previous chapter, right? So let us now have a connect between these two. So electrical energy will be equal to electrical energy which will be equal to, let us consider if no 1 farad electricity will be produced if 1 mole of electron, if 1 mole of electron is passed through the cell. So 1 farad electricity will be equivalent to if 1 mole of electron transfer. If n mole of electron transfer, then if n mole of electron transfer, that means no n of electricity will be produced, right? So n is the number of electron that is transferred, f is the Faraday's constant that is equal to 965, nearly 96500 coulomb. So let us apply that here. The electrical energy produced which is equal to NF into E cell, where E is the EMF of the cell. So let us have this equation here, and the electrical energy produced which is equal to NF E cell. All we need now this cell potential. If you have the cell potential EMF of the cell, you can find the amount of electricity produced in a galvanic cell. Now let us now think think about a reversible cell. In a reversible cell, it is observed that the decrease in free energy, that we represent as minus delta G. This now everybody knows, right? Because feasibility of a chemical reaction cannot be predicted by change in Gibbs free energy. If delta G is negative means reaction is spontaneous. If delta G is no 0 means that's equilibrium. If delta G is greater than 0 means that is non-spontaneous. So that's the way now we always familiar with the delta G, which is we call change in Gibbs free energy. So decrease in free energy, which is equal to the electrical energy that is produced in a reversible cell, in a reversible cell, the decrease in free energy will be always equal to the electrical energy that is produced. So let us now connect here. So instead of electrical energy, you can put minus delta G. Minus delta G is equal to N of E cell. So let us have this equation in mind. So we found an equation to find to have a relationship between change in Gibbs free energy and cell potential. Now let us continue from here, because now we still want to derive more. Let us connect now. So let us remember the equation for Gibbs free energy. Delta G is equal to delta H minus 3 delta S. This is the equation for Gibbs free energy. where delta G is the Gibbs free energy, change in Gibbs free energy, delta G is the enthalpy of the reaction, change in enthalpy, T is the temperature, delta S is the change in entropy. So let us have that in mind. Okay. So now let us apply Gibbs-Helmholtz equation. Gibbs-Helmholtz equation means no here H-E-L-M-O-H, Gibbs-Helmholtz equation, M-H-O-L-T-S, Gibbs-Helmholtz equation. In Gibbs-Helmholtz equation, we actually finding a relationship, we applying a relationship for delta S in terms of Gibbs free energy and temperature. So we have an equation in thermodynamics, dou G by dou T at constant pressure, which is actually equal to minus delta S. This is something that we derive in thermodynamics. So change in Gibbs free energy with respect to temperature at constant pressure is actually equal to change in entropy, minus of change in entropy. So let us apply this particular equation here. So we can now find a relationship in terms of Gibbs free energy. Dou means now partial derivative. So dou G by dou T with respect to with the constant pressure is actually equal to minus delta S. So let us apply that. So here delta G will be equal to delta H plus this minus S we are going to substitute here. So T into dou G by dou T P. So that's a famous equation for Gibbs free energy in terms of in terms of enthalpy and temperature. This we can say it's a temperature coefficient in terms of Gibbs free energy at constant pressure. Now let us apply. We already saw delta G is equal to NF E cell, right? So let us apply so that now we have a relation for cell potential as well. So NF E cell, I just apply delta G is equal to NF E cell, which is equal to, let it be equation 1, and delta H plus T into delta G is equal to minus NF E cell, or minus delta G is equal to NF E cell. Okay. So minus NF E cell, which is equal to delta H plus T into minus dou of minus NF E cell divided by dou T at constant pressure. Right? I just applied what is delta G. Instead of delta G, I applied minus NF E cell. Now here you can see NF, here also NF is there. So let us have this minus. Let us change the minus sign. So NF E cell, which is equal to minus delta H minus we can remove. So you will get temperature NF are constant. So you can take that outside, NFT into dou E by dou T. Dou E by dou T at constant pressure. NF is equal to minus delta H plus NFT into dou E by dou T at a constant pressure. So we have that equation. NF cell is nothing but electrical energy produced, right? NF cell is equal to electrical energy produced minus delta H is the change in enthalpy. NFT are constant is temperature, and dou E by dou Tp. If we have change in Gibbs energy with respect to temperature at constant pressure, if you have this value, you can find the amount of electrical energy that is produced. So now let us compare, because how we can compare delta H and amount of electrical energy produced. Now just keep in mind the sign. If dou E by dou T is positive, if dou E by dot T, that is positive. If dou E by dot T is positive, then you think here, then with respect to rise in temperature, as the temperature increases now, this part become more positive. This part become more positive means now, you, as the temperature increases now, this is minus, this is plus, so you tend to get a positive value. Electrical energy will be more positive as the temperature increases now, if dou E by dou T is positive. So you get electrical energy increases. Electrical energy will be positive. Electrical energy will be positive with respect to rise in temperature. Now another case, if dou E by dou T is negative, so electrical energy will be released, because now you think in terms of delta H. Delta H will be no, delta H value will be will be lesser. This become more positive. That why you getting a positive value. So if dou E by dou T is negative, means this part is negative, this part is also negative. So electrical energy will be less than if you compare in terms of enthalpy, electrical energy will be less than delta H. So electrical energy will be is lesser than enthalpy of reaction. Now next case, if dou E by dou T is 0, dou E by dou T is equal to 0 means this part is gone, which means amount of electrical energy produced, that is exactly numerically exactly equal to enthalpy of reaction. So this is the way you can think. In the first case, dou E by dou T is a positive, means with the rise in temperature this will be more positive, which means this electrical energy will be produced greater than, have a value greater than enthalpy of reaction. This case, if delta dou E by dou T is negative, means this part is negative, this part is also negative. So you actually getting electrical energy which is lesser than the enthalpy of reaction. Another case, dou E by dou T is equal to 0. Dou E by dou T is equal to 0 means this part be numerically equal to delta H, or change enthalpy of the reaction become equal to the electrical energy produced. So that's the way you can have this equation. Keep this important equation in your mind. N of E cell, which is equal to minus delta H plus N of T dou E by dou T, because that's required in the other part as well. Okay, so we already have an equation for delta G, which is equal to minus N of E cell, right? So now let us try to find an equation for delta H and delta S as well, change in entropy. So now here, if you want an equation for E cell, you can still derive. Okay, here E cell will be equal to, let me write here, E cell which is equal to divided by NF. Throughout you just divide the whole equation by NF. So dividing NF will be cancelled. Here minus delta S divided by NF plus dividing by NF means that will be gone. T into dou E by dou TP. So just now have this equation also in your mind. Now let us derive an equation for delta H. So delta H will be equal to, so here you want an equation for delta H means let this be positive, means this will come here. So delta H will be equal to N of T into dou E by dou T, dou E by dou T, N of T into dou E by dou Tp minus N of E cell, N of E cell. Let us now have an equation for delta H from this equation. Let it be equation 2 something. So from the equation 2 we have an equation for delta H. Delta H is equal to N of T into dou E by dou Tp minus N of E cell. So now just let us Take NF outside. Delta H is equal to NF into T into dou E by dou T P minus E cell. So this is the equation that you can remember to find delta H. Change in enthalpy is equal to NF into T into dou E by dou Tp minus E cell. Okay, so we found an equation for delta G and delta H as well. Now we want to derive for a delta S, right? So from where we can start? Okay. Now this is something that we derived before. So let us start with the Gibbs equation. Delta G is equal to delta H minus T delta S. So delta G we applying now delta H plus T into dou E by dou T P. Dou G by dou T P. So this equation we already done it before. So instead of delta S we put T into dou G by dou Tp, which is exactly equal to delta S, right? Now applying delta H is equal to NF E cell minus NF E cell, NF E cell, which is equal to delta H plus T into dou G by, instead of dou G, NF E cell, NF E cell minus NF E cell by dou Tp. Okay, so now just take now enough outside. Right, so here delta G minus delta H, which is equal to delta G minus delta H, delta G minus delta S, which is equal to T. So NF minus NF E cell, which is equal to delta H plus T into dou NF E cell divided by dou Tp. Here now, this is actually equal to delta G. So delta G minus delta T, delta G minus delta H, which is equal to T into NFT. Let us take NF outside, NFT into dou E by dou T, dou E by dou Tp. So let us have this in mind, delta G. So instead of NFE cell we put delta G, because now delta G is equal to minus NFE cell, delta G minus, you have taken delta H here, delta G minus delta H is equal to NFT I have taken outside, NFT into dou E by dou Tp, right? Minus sign is there, right? Yes, sorry, here minus sign is there because now here delta G6 should be equal to minus NF cell, right? So yes, so delta G minus delta H is equal to minus NFT into dou E by dou T. So let us have that in mind. Now we know delta G is equal to delta H minus T delta S. So let us take delta G minus delta H, which is equal to minus T delta S, right? Minus T delta S, right? So let it be equation 2, let this be equation 1. So we have two equation, delta G minus delta H is equal to minus NFT into dou E by dou TP, and delta G minus delta H is equal to minus T delta S. So compare these two, you can see left hand side are equal. So these two can be equated, which is equal to minus NFT into dou E by dou T, dou E by dou TP, which is equal to minus T delta S, right? Yes. So let us know, minus minus will be cancelled, temperature T will be cancelled. So what is left? What is left is so minus will be cancelled, T also will be cancelled. So directly getting delta S. Delta S, which is equal to NF into dou E by dou TP, dou E by dou TP, NF into dou E by dou TP. So that's the equation for delta S for it. So we derived three equations, that is delta G is equal to minus NF cell. Then now we have an equation delta H is equal to NF into T into dou E by dou TP minus E. And now we derive an equation for delta S, which is equal to NF dou E by dou TP. So this is the three equations that you can remember. Now if it is now in the standard condition, then now we have, so this equation will be like this, where delta G 0, no, if we measuring Gibbs free energy in the standard condition, so delta G 0 will be equal to minus NF E0 cell, standard EMF. Then delta H, we already derived delta H0 will be equal to standard enthalpy change, which is equal to NF into T into dou E by dou T, dou E0, dou E by dou TP minus E0, dou NF into T into dou E by dou E0 divided by dou TP minus E0. Now for delta S, standard entropy change, delta S0, which is equal to NF into dou E by dou TP. Okay, so these are the three equations for the standard Gibbs free energy change, standard enthalpy change, and standard entropy change. Okay. So in the next class we can do some problem related to this, and we can have a thermodynamics derivation of Nernst equation. We can discuss in the next class. Okay. Thanks for listening. Let us find out.